Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel. By the way, we're taping on Cinco de Mayo, although this is being posted on the 6th of May. So we hope you had a wonderful Cinco de Mayo party.
Yeah. And just be responsible.
Yep.
Yeah. And today we're talking about this is an interesting story. It has to do with trees and let's just talk. Yeah, just trees. So
there's a reason why you don't get under trees when there's a lightning storm.
Yeah, exactly.
All right, researchers have captured the first real-world evidence of tiny electrical flashes glowing from treetops during thunderstorms. These nearly invisible bursts may help clean the air while revealing a hidden side of forests. In June 2024, a team of Penn State researchers set out along the East Coast in a modified 2013 Toyota Sienna, equipped with a custom telescopic weather instrument mounted on its roof. Their mission was to track Florida's frequent summer thunderstorms and capture evidence of a phenomena that had never been observed outside laboratory conditions. Would you like to know more?
They were searching for corona discharges, a long-suspected atmospheric effect in which tiny electrical pulses form at all the tips of leaves, causing treetops to emit a faint glow in the ultraviolet. That's just
ultraviolet light spectrum.
Yeah, that's just so weird. For more than 70 years, scientists have linked unusual electric field activity in forests during storms to this effect, but direct observations in nature had remained out of reach.
Breakthrough. The group included William Brune, not making that up, a distinguished professor of meteorology and atmospheric science, Patrick McFarland, a doctoral student in the same field, Jenna Jenkins, an assistant research professor, and David Miller, a former associate research professor, now working at Penn State Applied Research Lab. We hope if they're watching this, they can make a comment. Their goal was to become the first to document corona discharges occurring in the natural environment.
Florida was selected because of its regular thunderstorm activity. However, conditions did not unfold as expected. For 3 weeks, McFarland and Brune pursued brief, scattered storms that faded quickly, leaving the team without meaningful results.
The turning point came as the researchers began their journey back to Pennsylvania with their tails tucked between their legs. Large, long-lasting storms developed just west of Interstate 95. The team pulled off the highway and set up in a parking lot at the University of North Carolina at Pembroke. From there, they directed their instruments toward the upper branches of a sweet gum tree located about 100 feet from their vehicle.
A storm lasted nearly 2 hours. That's pretty long, producing steady rain and repeated lightning. During this time, the team detected corona discharges on the sweet gum tree and later observed similar activity on a nearby long needle loblolly pine as the storm weakened. These observations marked the first confirmed detection of corona discharges in nature. The findings were published in Geophysical Research Letters.
Quote, "This just goes to show that there's still discovery science being done," said McFarland, lead author on the paper. They're discovering new species of animals and insects.
Right.
Continuing his quote, "For more than half a century, scientists have theorized that corona exists, but this proves it."
The researchers explained that corona discharges arise from strong electrical imbalances during thunderstorms. Storm clouds build up negative charges, which attract positive charges from the ground below. This positive charge travels upward through the trees, concentrating at the lowest points, such as the tips of leaves.
Okay. At these fine hair-like structures, and that was at the highest points. At these fine hair-like structures, the electric field becomes intense enough to produce a faint glow in both visible and UV wavelengths. The UV light generated during this process breaks apart water vapor, leading to the formation of hydroxyl.
Hydroxyl plays a crucial role in atmospheric chemistry as the primary oxidizer. Oxidizers help cleanse the air by reacting with various chemicals and converting them into forms that can be more easily removed. These reactions involve substances released by trees as well as human-produced pollutants, including methane, a greenhouse gas.
Previous studies by the team showed that corona discharges could be an important source of these cleansing compounds within forest canopies, suggesting a potential link between storms, trees, and air quality.
Earlier experiments conducted by the researchers involved applying high voltage, low current electrical pulses to tree branches. These tests revealed a strong connection between UV emissions from corona discharges and the production of hydroxyl. Both in those experiments and in the recent field observations, the team also noted minor damage to leaves as the points where corona formed.
To observe the phenomena in real-world conditions, the researchers developed the Corona Observing Telescope System. This system was a Newtonian telescope connected to a UV-sensitive camera. It includes geolocation capabilities, instruments to measure atmospheric electricity, and calibration using a mercury lamp. By blocking solar UV wavelengths, the system ensures that only corona, lightning, and fire can produce detectable UV signals.
Using the system in North Carolina, the team recorded 859 corona events on the sweet gum tree and 93 on the loblolly pine. Individual events lasted from brief flashes to several seconds, according to McFarland. The researchers also observed corona activity during 4 additional thunderstorms and across 4 other tree species.
Quote, it's nearly invisible to the naked eye, but our instruments give rise to a vision of swaths of scintillating corona glowing as thunderstorms pass overhead, McFarland said. Such widespread coronae have implications for the removal of hydrocarbons emitted by trees, subtle tree leaf damage, and could have broader implications for the health of trees, forests, and the atmosphere.
Although the study confirms that corona discharges occur in nature, many uncertainties remain. Researchers are now investigating whether these electrical current or events harm trees or provide them some benefit. They are also exploring whether trees have adapted to withstand this process and whether the resulting chemical reactions improve forest health.
Very interesting.
I guess. You want me to read that last one? You want me to read the last one?
I guess.
To answer these questions, the team is beginning collaborations with tree ecologists and biologists. Would those be tree huggers?
Yeah.
Their work could deepen understanding of how forests interact with the atmosphere and influence environmental processes. Okay, well, I don't know if that affects my life during the day of my normal day, but I'm sure it affects some people. So
keep your eyes open when there's a thunderstorm. Look at your trees.
Get away from the trees, right? We all confirm that, right? Who knows how those trees are going to react? So,
yep.
All right.
Thanks for joining us. We'll see you tomorrow.
We'll see you all tomorrow. Take care. Thanks for subscribing.